Hello and welcome back to the deep dive. Today, you're in for something a bit different, I think. We're going to take what might seem like a pretty niche area exam practice questions and use it as a shortcut, really, to understand some critical parts of modern cloud security. Specifically, we're digging into Fortinet's way of securing these really dynamic cloud and hybrid environments. We're drawing insights from the FCSS CDS AR 7.6 exam material. Now, just to be clear, the goal isn't exam prep itself, the 38 questions on FortiGate 7.6 and FortiWeb 7.4. No, instead, we're aiming to pull out the really important stuff, the core strategies, the key integrations, and sort of the why behind how Fortinet products mesh with AWS, Azure, GCP, you name it, to keep things safe and running smoothly.
Exactly. And what's really interesting, I find, is how these focused scenarios, like the exam questions, they really shed light on practical answers to actual real-world cloud security problems. It's not just about passing a test. It's about understanding the core mechanics, the things that give you strong security, high availability, automated responses, all that stuff you need in these complex cloud and hybrid setups. So yeah, our mission today is to link these specific Fortinet features to that bigger picture cloud infrastructure operational efficiency, see how they fit together.
Right. I like that frame. It shows how these specific points become like design principles almost. Okay, let's start with that cloud-native integration piece, because cloud environments, they're always changing, aren't they? Resources pop up, disappear, IP shift. It's constant flux. So how does Fortinet keep up automatically? How do policies stay relevant?
That is the exact problem Fabric connectors are built for.
Yeah.
Think about, say, a big AWS setup, new EC2 instances launching, others shutting down all the time. Each one gets a dynamic IP. Now, if your firewall rules rely on static IP lists, well, you're constantly playing catch-up manually.
Which means gaps in security.
Big gaps, and it's just not scalable. So Fabric connectors, they basically let the FortiGate talk directly to the cloud platform's API, AWS, Azure, GCP, whatever. It pulls in that dynamic info, like the new EC2 IPs, automatically.
Okay.
And it updates its own address objects. So the security policies that use those objects, they adapt on the fly, no human intervention needed.
So the firewall becomes aware of the infrastructure changes itself?
Precisely. It's self-adapting. It keeps your security in sync with your actual constantly changing cloud footprint. It's really fundamental for agility, for making sure those policies don't become outdated the minute something changes.
Okay, that makes a lot of sense for dealing with the dynamism. But what about, when things break? Cloud resources aren't infallible. How do we make sure security stays up during, say, a failover?
Yeah.
Especially in an HA configuration.
Right. Resilience is key. And this is where, in Azure specifically, the Azure SDN connector becomes absolutely vital for HA. Imagine you've got a FortiGate HA pair in Azure. If the primary unit fails, you need traffic to switch over to the standby unit instantly, seamlessly.
Naturally.
But Azure's own routing doesn't just magically know to do that. You need to tell it where the new active FortiGate is. That's where the SDN connector comes in. It uses something called user-defined routes, or UDRs. Think of them as custom traffic rules for Azure. The connector's key job during a failover is to automatically update these UDRs to point traffic to the newly active FortiGate.
It changes the Azure routing rules.
Exactly, automatically. Yeah. So traffic flow redirects immediately and correctly. Without that automated UDR update, the failover just wouldn't work properly. Traffic might get dropped or bypass the firewall entirely.
So the connector is the linchpin making the HA actually work in Azure.
It really is. It ensures that security service stays online and effective, even when a device fails. True high availability.
Okay, got it. So we've covered adapting to change within one cloud, ensuring resilience. But most places aren't just in one cloud, are they? What if you have FortiGates scattered across AWS, Azure, maybe on-prem too? How do you keep it all manageable? How do you respond quickly if something happens anywhere in that mix?
That's the multi-cloud headache, right? And FortiManager's automation stitches are, frankly, a lifesaver here. Trying to watch and react to events on hundreds of devices across different platforms manually, it's impossible, or at least impossibly slow and error-prone. FortiManager is that central command console, and the automation stitches let you set up predefined automated responses that work across all the FortiGates it manages, no matter where they are.
How does that work? Like, if X happens, then do Y?
Pretty much exactly that. You define triggers. Maybe a specific threat is detected or a compliance policy is violated, and then you define actions, quarantine the source IP, block an application, push out a policy update globally, whatever makes sense.
So it links cause and effect automatically across the whole estate.
Yes. So a threat pops up in your AWS VPC. An automated action can immediately block that threat actor not just there, but also in your Azure setup and your on-prem firewalls, all without anyone needing to manually log in and do it. It means faster response times, consistency, less chance of human error, and honestly, less alert fatigue for the security team. It shifts things from purely reactive to more proactive orchestration.
Okay, so stitches automate the response. But what about seeing what's going on in the first place? How do you get visibility, especially tailored insights, across all those different cloud instances, not just a flood of logs?
Yeah, visibility is the other side of that coin. And that's Fortinet territory. Think of it as the intelligence and analytics engine to FortiManager's orchestration. You often need very specific reports, right? Like, show me all blocked malicious traffic from all my cloud FortiGates, grouped by region.
Yeah.
Or, what were the top 10 attack types across AWS and Azure last week?
Standard reports probably won't cut it for that level of specifics.
Exactly. Generic reports are rarely enough. So FortiAnalyzer has this powerful data set and chart library. It lets admins define exactly what data they want to pull from all the connected FortiGates, logs, events, whatever. Then they can build custom charts and assemble them into really specific, tailored reports.
So you define the view you need.
Precisely. It's about turning that mountain of raw log data into actual, actionable intelligence. Insights that are directly relevant to your specific multi-cloud security posture, your compliance needs. It helps you understand what's really happening, not just collect data.
Makes sense. You need both the central control and the tailored visibility.
Okay, let's pivot slightly. Many organizations have that hybrid setup stuff, on-prem, stuff in the cloud. How do you securely link those worlds and maybe even make the connection work better, faster?
The classic hybrid cloud challenge. This is where FortiGate's SD-WAN features really shine, usually working hand-in-hand with IPsec VPNs. So the typical scenario is connecting your on-premises network securely to, say, your AWS VPC. You've got FortiGates at both ends. For that secure site-to-site link, IPsec VPN is generally the go-to tunnel type. It gives you that encrypted secure pathway.
Standard stuff for site-to-site.
Right. But where FortiGate adds value is layering its SD-WAN intelligence on top of that. You might have multiple internet connections, maybe a direct connect link as well. SD-WAN can manage traffic across multiple IPsec tunnels running over these different paths. It can measure latency, jitter, packet loss on each path, and intelligently steer application traffic like VoIP or critical business apps over the best performing path at any given moment.
So it's not just secure, it's optimized for performance too. Exactly. IPsec provides the secure foundation, the tunnel. SD-WAN adds the brains to manage traffic dynamically across those tunnels for better performance and reliability. That's how you really bridge the on-prem and cloud worlds effectively for your applications.
That's a neat combination. Okay, let's get into some specific threats. Web attacks are always a concern. SQL injection, still a classic, still dangerous. If a FortiGate is acting as a WAF, say in AWS, how does it stop that?
Good question. For SQL injection, the key FortiGate feature you need is the Intrusion Prevention System, or IPS. SQL injection is fundamentally about injecting malicious code, right? Trying to trick the backend database via web inputs. It's an exploit.
Okay.
So the IPS security profile is specifically designed to look for the signatures and patterns of those kinds of exploit attempts. It inspects the traffic payload for malicious SQL commands. Other profiles, like, say, web filtering, that's more about blocking access to categories of websites. Application control is about identifying and controlling specific apps. Neither of those is really designed to dissect SQL injection code itself.
So IPS is the specialist for finding those attack patterns.
Precisely. It's engineered to spot those malicious commands trying to manipulate your application and block them. It's a direct defense against that type of exploit.
Got it. Now, thinking about modern web apps, containers, Kubernetes, it's a different world. Dynamic, API-driven. How does something like FortiWeb fit in to secure applications running inside Kubernetes?
Yeah, Kubernetes security is a whole different ballgame because things are so ephemeral and interconnected via APIs. The best way to use FortiWeb here isn't just placing it outside the cluster, it's deploying it as an ingress controller right inside the Kubernetes cluster.
As an ingress controller, what does that mean practically?
So an ingress controller in Kubernetes is basically the traffic cop for external access. It manages how outside traffic gets routed to the different services running inside the cluster. By deploying FortiWeb in that role, it sits right at the entry point for all HTTP PHTTPS traffic coming into your applications within the cluster. It can then inspect that traffic, apply WEF policies, look for SQL injection, cross-site scripting, all those web threats before the traffic even reaches your microservices.
So it provides Wave capabilities natively within the Kubernetes traffic flow.
Exactly. It's integrated right into the cluster's networking fabric, providing that crucial security layer for modern, containerized apps right where it's most effective.
Makes sense for those environments.
Yeah.
Okay, what about the really nasty stuff, the unknown threats, 0 days? How do you defend against malware nobody's ever seen before, especially if it's, say, uploaded to cloud storage like Azure Blob?
That's where you need something beyond signature-based detection. You need sandboxing, and that's FortiSandbox's role. FortiGate IPS and FortiWebWay are great for known threats and common attack vectors, but zero-day malware is specifically crafted to slip past those defenses.
Because there's no signature for it yet.
Exactly. So imagine someone uploads a file to Azure Blob Storage. It looks harmless, passes initial checks, but it contains brand new malware. FortiSandbox integrates with services like Blob Storage. When a suspicious file arrives, FortiSandbox takes it and runs it in a safe, isolated environment, the sandbox. It watches what the file does. Does it try to encrypt files, call out to malicious domains, exploit vulnerabilities? It analyzes the behavior.
Regardless of whether it matches a known signature.
Right. It's looking for malicious actions, not just known patterns. If it detects bad behavior, it flags the file as malware, even if it's never been seen before. It's that critical layer for catching novel threats that would otherwise get through. Proactive behavioral detection.
That feels like a necessary layer for advanced threats. Okay, let's shift back to infrastructure a bit. Building this stuff securely. How do you get the right level of visibility in the cloud, especially for things like troubleshooting firewall rules or doing audits?
Visibility is crucial, you're right. In AWS, for instance, flow logs are key. But the devil's in the details. If you want really detailed traffic info for your FortiGate, specifically including traffic, it denied just enabling VPC flow logs at the top level isn't quite enough.
Why not?
It gives you a broad picture, but for the specifics of what hit the FortiGate and what decision it made, you need to enable flow logs right on the FortiGate's network interface. That's the Elastic Network Interface, or ENI in AWS terms.
Enable logs at the ENI level.
Yes. Enabling flow logs directly on the FortiGate's ENIS captures the most granular data about traffic hitting that specific interface. Critically, this includes records of sessions the FortiGate actively blocked based on its policies. That level of detail is gold for troubleshooting why something isn't working, for security forensics investigating an incident, or for auditing that your policies are actually being enforced correctly. You see both the allowed and the denied traffic specific to the firewall itself.
That makes sense. You need that specific viewpoint. Okay, last piece, building it all. Lots of folks use infrastructure as code now, like Terraform. Is there a right order to deploy things, like cloud stuff first, then FortiGate, or the other way around?
Oh, there's definitely a right order. It's a fundamental IIC principle, really. You must deploy the underlying cloud infrastructure first. Then you deploy and configure the FortiGate.
Why is that sequence so important?
Because the FortiGate configuration depends on the cloud infrastructure existing. It needs a VPC to live in, subnets to connect to, network interfaces with IP addresses, maybe route tables it needs to influence, load balancers it sits behind. If you try to apply the FortiGate Terraform configuration before the VPC, subnets, and ENIs are actually created, Terraform will just fail. It can't configure something on infrastructure that doesn't exist yet.
Like trying to hang a picture before the wall is built.
Exactly. You build the foundation, the EPCs, subnets, routing, then you place and configure the security appliance within that foundation. Understanding that dependency is key to making IIC work smoothly for network security deployments. As these cloud environments get ever more complex, ever more dynamic, how does this kind of deep integration and automation start to change the job of the security architect? Is the focus shifting away from painstaking manual configuration towards more strategic orchestration, designing and overseeing these intelligent, self-adapting systems? Because the principles we touched on today, they're not just about Fortinet, they're about the future of smart, adaptable security in this whole cloud era. Keep exploring those connections, keep thinking about that shift, and you'll be in a good position for whatever comes next in cloud security.